Greetings. I, Dr. N.K. Sakthivel, would like to welcome you all back to this video session. My dear learners, my dear children, so every day I posted a video focusing MCQ questions for each units on the subject multi-core architectures and programming, which is Anna University syllabus under Regulation 2013. As you know, Anna University is like to conduct end semester examination, it's an online examination under MCQ pattern, which is going to start from 22nd to 29th September 2020. So the previous videos we focused Unit 1 and Unit 2 as well. In this video, I would like to explain the keywords and possible MCQ questions on Unit 3. As far as Unit 3 is concerned, it's focusing shared memory programming with OpenMP. You know very well what is OpenMP. OpenMP is nothing but Open Multi-Programming. M refers multi and P refers programming. Open Multi-Programming. And the word open refers, it is the open source. So, OpenMP is the compiler, open source compiler, and the prime objective of OpenMP is focusing parallel programming. So that multi-programming is also called as multi-thread, you know very well. Okay. And this OpenMP we calling as Application Programming Interface, API. Okay. So please understand this open multi-programming or multi-thread is the what is called interface, application programming interface, and the prime objective of this model for executing multi-thread or the parallel programming. So with this idea, I would like to highlight and explain few keywords which are coming under Unit 3, and after that we would like to focus and discuss MCQ questions. Okay. So first, okay, the keywords please understand and remember and apply and analyze for answering correct answer for all the MCQ questions which is going to rise in our university examination. And these are the keywords and plus some other keywords also and plus actually this. So all these keywords we would like to discuss one by one to understand the meaning and the purpose of those keywords, those mechanisms and those tools. And after that we will discuss MCQ one by one. I welcome you all back to understand the concept once again. So before focusing and the keywords, please understand the OpenMP, Open Multi-Programming is designed for parallel execution. I already told you. And the keywords, the object to call OpenMP or to call the API is OMP, Open Multi-Programming, OMP. And this is the one set of program. And this is another set of program. And this is the third set of program. And like this, I am showing 1, 2, 3, 4 and 5 programs. The purpose is to understand okay how OpenMP helping for parallel programming. So nowadays we wanted fantastic mechanism, the hardware architecture to execute a very complicated project with a short period. The idea is even the project may be a very complicated, very time consuming process, but I wanted to get the result within a nanosecond or microsecond or in terms of millisecond. I don't want to wait my prestigious time for getting this output. That's the reason why everybody focusing parallel programming and supercomputer, you know very well. So for this purpose, the OpenMP was introduced. You know OpenMP is the fantastic mechanism. See the first program. Okay, that is this program is designed under the parallel execution and I wanted to print this hello world. So how if it is ordinary processor is there? Okay, the ordinary processor will print hello world in one time, then during the next iteration second time, and the third time, and the fourth time. Whereas in this OpenMP, the hello world will be printed in parallel. Okay, see the output, you can understand. So for example, here one output will be printed, hello world. At the same time, this will be printed, and the third will be printed, and so on, so forth. The idea behind is, so parallel execution, so that what are the instructions are independent, the word is very important. What are the instructions are independent, those instructions will be combined together, will be identified and combined together by OpenMP, and then those instructions will be executed in parallel, so that with a short time, okay, we will get the result. As far as this program is concerned, okay, so that is how many parallel execution, no specification there, so that the system itself, OMP itself will understand, okay, will understand how many processors in the programming, in the system. For example, 4 processors available, now the parallel execution is 4. Imagine that 64 processors are available on the computer, then the parallel processing is 64. So like this, depends upon the number of processors, the hello world will be executed in parallel. According to this diagram, it is a 4. Okay, if it is 8 processors, 8 print will be executed in parallel. So this is one idea. Okay, come down to the next program. So in this program, so actually in this parallel, we have given, okay, how many parallel execution has to be executed. Okay, so number threads, and I have given that is a 7, means that the hello world will be printed 7 times in parallel. Okay, that means 7 parallel execution, 7 print print statements will be executed. So that is a parallel execution. This is a second program. And in this third program, okay, we have given that is a for loop, and the for loop, okay, what is called 6 times. So obviously 6 times will be executed. Okay, so these are the one ideas. So you understand the place OpenMP proposed for parallel execution. Okay, and after that, the one more idea here is introducing a section. Section is nothing but for each section there is a one control. That means here hello world means all the 7 threads will be executed hello world only. That's a problem here. So whenever you are introducing a section, okay, here that is a one type of instruction will be executed parallel, and that is hello world 2, that's another input will be executed in parallel. Third one is hello world 3 is another input will be executed in parallel. It means that if you are introducing section, 3 different tasks can be executed in parallel. Understand? So if I wanted to execute different instructions, different tasks, but in parallel wanted to execute, you can use what is called a section. So this is the idea. Okay, and similarly here also the parallel execution. So from this what is called the programs model, please understand open multi-programming or the multi-thread, or it is called API, designed for parallel execution. And that OpenMP compiler, how shall we call for this? This is a command, is Pragma. Okay, so this is a command. Please understand. And with this idea, I would like to highlight, okay, and this also one of the inputs. Let us consider I am running this program. So that is a hello.c was created, and I am executing this program. Okay, according to this program, okay, 3 parallel executions. So 3 threads created, and under this threads, okay, sub threads and all there. So these are the possible outcome of the parallel execution. Please note it down. Here that is a one sequence, and here is another sequence, and here that is a different sequence. So please expect, so depends upon the group of threads, and those threads are sequenced in a manner so that all what is called the threads are executing in parallel. Okay, it's a small introduction. Okay, we have it is a very good model, but I am not going to demonstrate those model. But now we are focusing keywords, and for keywords, I would like to explain the meanings and the MCQ. Okay. So that is the first keyword. So first keyword is OpenMP. So you know very well what is OpenMP. I already told you. Open multi-programming, and open refers open source, and the multi-programming we can call as multi-thread, and this OpenMP we can call as interface or API, that is called application programming interface. Okay, the prime objective of this OpenMP was designed and proposed for multi-thread application, the parallel execution also. Okay, and this what is called API interfacer can be what is called configured with the C compiler or the C++ compiler, and olden days we used this with Fortran also, but we are not using Fortran now. Okay, that is C and C++ compiler. So the OpenMP API can be configured with the C or the C++ compiler, and you can enjoy parallel execution. So this is the idea behind OpenMP. And the next keyword is Pthread. So P refers what is called parallel. So parallel threads. So Pthread is nothing but execution model, and it is also called as a parallel execution model. So Pthread is the mechanism. Once you called this Pthread, okay, this compiler will start to execute parallel threads to execute in parallel mode. Okay, you can understand. This is called Pthreads. Okay, and the next one is MPI. So you know very well MPI refers message passing interface. So this is one of the standard, isn't it? MPI, message passing interface, and it is also called as library. The purpose is if you wanted to transfer large volume of what is called files, or that is data or any information from one thread to another thread, so you can use this MPI under OpenMP. And the next one is initial task region. So the initial task region is a very important concept because it is useful for executing in parallel model. So what is initial task region? So it is a thread to execute the task in sequential. Okay, so initial task region, okay, under the region we can create or we can initialize a thread, okay, that will be executed in sequential. Sometimes whenever calling any threads under initial task region and implicit, okay, a particular range, that means from one particular area to that is another area, all those instructions, that means all those threads will be executed in sequence. Okay, so if you wanted, we can modify this into parallel region also. Clear? So that is the initial task region is used to execute instructions sequentially, and it is an implicit task region, or it is also called as initial task region. Why it is called implicit task region? Reason because if you are restricting one good area, okay, and those area instructions will be executed in parallel. It seems to be sequence but in parallel. Okay, so that is nothing but initial task region. I wanted to explain more about this one, tightly coupled, loosely coupled concept we wanted to explain, but please understand the concept alone. I am not demonstrating entire ideas. That's the reason why I would like to restrict the input at this level. Okay, so please understand initial task region is called implicit task region. It is also called as initial task region because in the particular regions, how many threads, how many instructions, how many processes are available, all those processes can be executed in a parallel model of a whole program. Okay, so that is the purpose of what is called initial task region. Okay. And the next one is we wanted to understand how to compile and run OpenMP. Okay, so if you wanted to compile and run OpenMP, okay, this can be installed under what is called a Linux compiler, GNU compiler, or with the Intel compiler. If you wanted to run Okay, this OpenMP under Linux compiler. So the command is gcc, then after that the space, then -o, then space, then omg, that is open multi programming, then that is a program. Okay, so during what is called MCQ questions, I will show the format and the pattern so that you can understand. Okay, like this you can execute. Okay. And the next one is, it is a Pragma. So already I told you the Pragma is for executing this OpenMP. It is called as compiler directives. Directives means executable. As far as directives we are mentioning under operating system, distributed operating system, it is called executable. So the Pragma is for compiler directives. That means compiler execution. And this Pragma are machine specific or operating system specific. Please understand different patterns, different models for computer configurations as well as different OS. Okay, the prime idea of Pragma is a compiler. So it tells the compiler to do something. That means it execute the instructions and like this. Okay, so that is a Pragma. And next one is fork joined model. So this is a very important one, fork joined model. See the diagram which I have shown in this right side. Okay, that is in fork joined model is used for executing parallel programs. It is considered as a parallel design pattern. So why it is called a parallel design pattern? See this diagram, you can understand. So that is fork model. And after that, okay, that is a different branches of threads, and each threads will execute a group of tasks. It is seems to be fork branches. That's the reason why it is called fork. And then after completion, all the threads will be combined together. Okay, all these executions, okay, will be executed in parallel. At the same time, this group of threads and this group of threads are totally different, independent. Okay, it is considered as the section. So you know very well, I already explained you. Section means, okay, under this, okay, one set of instructions can be executed. Under this section, different set of instructions can be executed. Similarly, in this third section. So this is called fork joined model. So for understanding purpose, fork joined model is strictly considered as parallel design pattern. And one more advantage is that if you wanted to execute in parallel, then you can use fork joined model in on what is called mode. If it is in the off mode, then the fork joined model can be executed in sequential manner. So that understand, it's a fork joined. Here, okay, that is single fork, and here also single fork. Okay, in this area, instruction is a sequential execution. Here sequential execution, when come to that is a fork level, and the threads and all splitted, for each thread group of instructions and all assigned, probably for loop iteration, okay, assigned. Then after that all these instructions are executing in parallel, or different teams involved to execute set of instructions. That's the reason why the fork joined model is a parallel design pattern. If you wanted, you can use this model as a sequential execution or the parallel execution. Okay. Next one is called as thread private memory. So from the name itself, it is clearly understand, okay, the thread has the private memory that can be used for its what is called operations purpose of storing data. Okay, so thread private memory, okay, has its own memory. It is called, it has its own private memory other than shared memory. So please understand, thread private memory concept is in here. Each thread, okay, has its own private memory, and okay, this thread can access shared memory also. Okay, so under this the thread private memory, we have, okay, shared memory model. Please understand, whenever shared memory model is coming, we wanted to focus consistency. So you know very well, okay, what is the consistency. I will explain later on what is consistency. Here you understand thread private memory, okay, is having one private memory as well as one shared memory. As this thread has a private memory, okay, so that the private data can be stored comfortably and can extract data for execution so that the system performance will go high. So that is the prime objective of thread private memory. So thread private memory you can introduce for increasing the performance, okay, because it has the private memory where its temporary data can be stored and whenever required it can extract, so that the thread no need to wait to extract data from the shared memory. This is the concept behind this. Okay. Next one is standalone directives. I already told you, okay, 1 minute please. Standalone directives. So the standalone directives called executive directives. I already told you directives means it is executable. So executable directives that has association with the user code. That means the standalone directives represent executable statements. That means different what is called API executable statements. It is called, like understanding purpose I tell you, that is a EXE program, and those EXE programs, or it is called as executable statements, can be combined together and those EXE statements can be executed with the help of standalone directives. Okay. So the standalone directives is executable, and not only that, it has certain constraints to place it in a program, because these exe programs cannot be executed in all locations. For example, if loop, while loop, switch, do, where and all, we cannot use standalone directives. So purpose is, it is a small exe code, okay, whenever required to execute the exe code, you can call those exe code with the help of standalone directives, but you cannot call under if, while, do and switch and all. So this is a very important one. Next one is called as the parallel directives. So you know very well the directives, okay, it is executable. So parallel directives means, okay, it can be executed with the help of multiple threads. That means multiple exe programs, the multiple executable statements can be executed on time. For this purpose, we are using what is called the parallel directives and parallel constructs. You know very well constructs. For example, in C programming, C++ programming, we are calling as constructor. The constructor is referred here as a construct. So you know very well what is a constructor. Constructor has the methods and what is called that is a method as well as the execution pattern. Both are the same name. So like this, in this parallel constructors, okay, it will call parallel directives and then it will execute. So parallel constructors or parallel constructs is called as a parallel executable thread, and it can be executed by parallel directives. So this is a very important one. Okay. So parallel constructs has the facility to call more number of parallel directives so that maximum parallel execution, that is parallel computing is possible. So this parallel constructs helps the programmer, especially industry people, to execute complicated tasks at the same time can get the result as early as possible. So that the parallel constructs is very important one. And the next one is called as section constructs. So what is the section constructs? The section construct is a non-iterative work sharing construct. So word is very important one. So section constructs is not iterative. That means a group of instructions is coming under a block. Then the block is called section construct, so that the particular block cannot be executed a number of times, only one time. That's the reason why it is called a non-iterative. Okay, and that is a work sharing construct means number of threads can be executed those instructions. So section constructs is the non-iterative work sharing construct. It contains a set of structured blocks that are to be distributed and executed by the threads. You know very well, because it is set of blocks, each block's number of threads, and those threads will be executed, okay, so that the task will be executed. Clear? So for this purpose, section construction are there. I already told you section construct means the best example this one. Okay, here that is a one section, here that is another section, is a third section. This section consists of set of processes. Those processes can be executed with the threads. Similarly here different tasks, and those tasks can be executed with the different threads, so that okay, different instructions can be executed in parallel. This is possible with the help of section constructs. And the next one is work sharing constructs. Okay, work sharing constructs. Work sharing construct is the main constructs. It is an executable thread, you know very well, shared by number of threads. Work sharing construct shared by number of threads. Okay, and this executable threads can share by other threads. For understanding purpose, I tell you this work sharing construct is like inheritance. Okay, so the work sharing construct, you imagine that one set is there, the same set you can copy it to another block and you can execute like inheritance. You can imagine inheritance, the like inheritance, this work sharing constructs will be used. And not only that, this work sharing construct, there are another what is called constructs and all there, that is called loop constructs, section constructs, single constructs. So if you wanted to use loop execution, or if you wanted to enjoy section constructs, you wanted to call work sharing constructs. So work sharing construct is a group pattern, consists of loop, section and single constructs. So why I am giving this input? Because in the MCQ questions they may ask you, okay, what are the constructs combined with work sharing? Okay, for example, if you wanted to call loop, first you wanted to call work share constructs. For this purpose I told you. Okay. Next one is odd even transportation sort. So what's the meaning of odd even transportation sort? So odd even transposition sort is a parallel sorting algorithm. So please understand, this is the great what is called model which is used to execute the instructions in parallel. So when you are using Openmp, you no need to write a parallel program. The system itself, okay, will execute your instructions in parallel after understanding independent task. Because you know very well, dependent task cannot be executed in parallel. Okay, so this can be possible, this can be achieved with the help of odd even transportation sort. So in this odd even transportation sort, you know that is a bubble sort. The bubble sort was integrated with this sort, so that if you are giving large volume of data to sort, okay, so this odd even transportation sort will sort your number with the help of bubble sort mechanisms, and it will sort in this ascending order. Okay, so odd even transportation sort, okay, is functioning with bubble sort technique to sort n numbers. Next one is message queuing. So you know very well what is a message queuing. Okay, that means for example a message is a group of information, a group of files wanted to transfer from one location to another location. I am speaking one process to another process. So those processes wanted to combine it together. In the first unit, you studied about pipe. That is the same concept is coming here. Okay, that is one process is creating a data, that is called producer, and another side one process receiving data, it is called consumer. You probably studied producer consumer concept. So producer continuously producing data, those data wanted to transfer to consumer. For this purpose we use pipe. Imagine that the pipe capacity is 10 instruction. For understanding purpose I tell you 10 instructions can be transferred in a second. Imagine that 11 instructions producer is sending. What will happen? So 10 instructions will be forwarded and one of the extra instructions will be stored in the queue. Then later on, whenever incoming is less, okay, then extra stored data will be forwarded to destination. You studied in networking queuing management system, okay, or queue model, okay, that is the message queuing. So the message queuing is a very important concept because this helps us to comfortably with a secured manner all processes, all tasks can be forwarded to another process. So that message queuing is a very important one. Next one is implicit barrier. So implicit barrier is nothing but it is a scheduler. It's a, simply speaking, it is a scheduler. Implicit barriers are the schedulers or the scheduling points. Okay, if a task is suspended in an implicit barrier, then that trade that is called some task within that barrier may be scheduled. Understand? For example, that implicit barrier is the area where let us consider more number of threads and all there. If I wanted to execute a particular thread and the thread wanted to call, once called, then that thread will be executed in parallel or will be scheduled to execute in parallel. For this purpose we use implicit barrier. So implicit barrier, it is helping like a room where how many threads are there, those threads can be executed in parallel. For example, if I wanted to, if I should not permit a particular task should not be executed in parallel, then that task should not go to implicit barrier. Understand me? So implicit barrier is like what is called one section. What are the threads going inside the sections? Those threads will be executed in parallel. Okay. For example, imagine that in the barrier, in the area, 3 threads are there. Thread 1, thread 2 and thread 3. Okay. Let us consider I am suspending thread 2. Meaning that thread 2 is going out. Then that thread cannot be executed in parallel. So that will execute in sequence. For what purpose it is used? So the implicit barrier purpose is, for example, one thread during execution, it has to handle dependent data, then that thread cannot be executed under parallel mode. So that implicit barrier sending out of that thread so that without any consequences, okay, that is dependent data can be executed. Okay, please understand what are the instructions we wanted to execute under parallel mode, that will go to implicit barrier. What are the threads wanted to execute under sequential manner, the threads will not be permitted to enter implicit barrier. So that compiler will understand, okay, if threads outside of implicit barrier should be executed as sequence. What are the threads within the implicit barrier will be executed as parallel. So this is a small introduction about implicit barrier. This is a very important concept. More points wanted to discuss on here. Reason because the scheduling is a complicated task in parallel programming. Simply we cannot schedule all the threads because some threads will handle what is called sensitive data, dependent data. Some threads will handle independent data, so that independent data alone can be executed under parallel programming. That's the reason why implicit barrier is a very important research area in OpenMP. Okay. And next one is OMP get thread num. It is a comment. OMP get thread num is the comment. So it is used to assign the rank, or it is used to get the thread rank in the parallel region. Imagine that, okay, tens of threads and all there in this implicit barrier. I wanted to get the rank of particular thread. For this purpose, we are using OMP get thread num. Okay, the OMP get thread num is used to get thread rank. Very, very important answer, because MCQ we may expect this question. And one more comment also there, OMP get num threads. It seems to be same. Please see here, OMP get num threads. So this is the thread mechanism used to assign the number to thread. So this is the mechanism to assign the number to thread, and this is the mechanism to understand the rank of the thread. Okay. Next one is, okay, that is caveats, and this is a very, very important one, caveats. Reason because it is handling in the sensitive block of the program. What's the meaning of sensitive block? For example, consider, okay, imagine that this loop I equal to 2, I is less than n, and I plus plus. 3 sections and all there, okay, under this for loop. Okay, if it is a single processor, sequential execution, no issue and all. First, okay, it will test the condition. The condition is true, okay, the block will be executed. After that, it will be incremented. Then, okay, will test, and it is going like this. When starting the first iteration, I equal to 2. You know that is a for loop concept and all. Here the problem is, OpenMP is the parallel execution. So if a parallel execution, so how that is a multi-threads can be executed under this. For example, thread 1 handling this. Imagine that thread 2, if it is changing this I value, thread 1 assigned I equal to 2. Imagine that thread 2 assigning I equal to 4, now the confusion will happen. So that's the reason why, okay, confusion means race condition will come. Race condition means, okay, the program will be terminated. So wanted to avoid this issue, so we have the concept called caveat. So is nothing but once the for loop execution started, one thread cannot handle another thread's, okay, variables like this. So some variables like this, okay, what is called initialization variable, conditional variable, increment variable like this, those variables cannot accessed by any threads. Imagine that under this for loop 5 threads and all available. All the 5 threads can update its shared variables. Okay, for example, let us consider m. M is the shared variable. That variable can be accessed by thread 1, thread 2 and thread 3. But at the same time, all the threads cannot change this value. For example, I cannot be updated. Okay, n cannot be updated because, okay, these variables are coming under caveat. That means without caveat knowledge, that means without compiler knowledge, individual threads cannot handle, cannot change, okay, cannot update these variables. For this purpose, the caveat we are using. So without caveat, okay, we cannot execute parallel execution. So the main purpose of caveat is used to avoid race condition. Okay, so that's the reason why the caveat is a very, very important technologies under OpenMP. Okay, and one more concept, data dependence or loop carried dependence. These are very important topics we may expect in MCQ. What is loop carried dependence? Both are the same, data dependence or loop carried dependence. So here, okay, imagine that when a statement in one iteration of a loop depends the value of the previous or the different iteration of the same loop. Understand me? Let us consider this block, you can understand. Okay, imagine that a particular block is executing. Imagine that, okay, now coming here, okay, particular iteration, okay, I value equal to 2. Let us consider I equal to 2. So that here B of 2 equal to 8. So 8 will be stored on the array of B of 2. No doubt on this. So this will be assigned to S1 thread. That is called a task S1 thread. And then coming here what's the I value? I equal to 2. So A of 2, okay, equal to B of 1. See here small conflict is coming, clear? So this execution, okay, because it is a parallel execution, if it is a sequential, no problem at all. So parallel execution, so in this iteration I equal to 2, 1 values, and here, okay, the processor has to take, or the task has to take the value of previous iteration. Understand? B of 0 value wanted to handle here. So this is called loop carried dependence. So whenever you have that is loop carried dependence, okay, but is called independent variables wanted to execute. If it is a dependent variable, race condition will arise. So that's the reason why loop carried dependence is very important one. So loop carried dependence nothing but if one iteration of the loops, okay, depends on the value of the previous iteration or the different iteration. See here one iteration I equal to 2. During this iteration, okay, so one value, especially B value, depends on the previous iteration value. So that is called loop carried dependence. Why I am focusing much here in this parallel computing, this is a major issue. This type of task can be executed in sequential manner only. So parallel execution, lot of confusion will come, so race condition. So that's the reason why my recommendation is that for looping, okay, this type of task should not be used, okay, for parallel execution. Okay. And the next one is scheduling. Okay. So the scheduling, okay, 3 types of schedules are there. Sometimes we can call it as 4 types. One is called static schedule, dynamic schedule, guided schedule, and the run schedule. Very important topics. Okay, definitely we can expect 2 or 3 MCQ questions on this area. So what's the meaning of static schedule? For example, 10 processors and all available. Okay, here 10 tasks and all available. Okay, for each processor, okay, one task will be assigned. That is called evenly dividing schedule, or it is called static schedule. So static schedule is concerned 10 processors, 10 processors, 10 threads. Okay, each thread will be passed to one processor. So equally allotted, equally load assigned. That is called static schedule. Static schedule is nothing but evenly divide loop iteration. Okay, no issue. And to whom it will assign? Okay, processor should not be overloaded. Okay. Next schedule is called as dynamic schedule. So dynamic schedule, okay, it will dispatch what is called that thread to the idle processor. So whenever you are handling a dynamic schedule, the task will be assigned to idle processor. That means under the dynamic schedule, no processor will be overloaded. Okay. Small difference in this guided schedule. Guided schedule also like dynamic schedule, but one difference is that under guided schedule, okay, the task will be assigned to the processor. Imagine that the processor is doing some other task. For example, let us consider me. I am taking 2 classes. Okay, one more class can assign to me. Okay, that is called guided schedule. Whereas in the dynamic schedule, okay, one professor do not take any classes, can assign the work. That is called dynamic schedule. So guided schedule, already process doing job. At the same time, one more task can be assigned to that processor. That is called guided schedule. But guided schedule will ensure that the processor will not go to overloaded. For example, I can handle 5 subjects, so that till 5 subjects the guided schedule will assign to me. But at any cost, guided schedule won't assign to me more than 5 tasks. Okay, that is called guided schedule. Okay, next and last one is called runtime schedule. So you can understand easily, runtime schedule is nothing but during execution, okay, the threads will be assigned, so that we do not know whether the processor is overloaded, whether the processor is underloaded or idle. But only thing is, okay, after assigning, it will verify the performance. If the performance of particular processor coming down, then some task will be reallocated to another process. Understand me? So for example, I imagine that I have the capacity to handle 10 classes. Then, okay, the schedule will assign it to 10. It won't restricted with 5 schedule or 6 schedule or 7 schedule. Understand me? If more than 10 tasks assigned, during the 11th task, I will take much time to complete. That means my performance going down. At that time, the task will be reassigned to another processor. So like this, that is a runtime. Okay. Static means what? Okay. It is evenly distribution. It is not possible. So that static schedule is not using under OpenMP. Dynamic schedule, okay, it will identify an idle process and the task will be assigned. Most probably no processor are in idle state, so that dynamic schedule also won't give fruitful result. So that guided schedule and runtime schedule are the best schedule as far as OpenMP is concerned. And the last topic is, okay, that is a coherence and the consistency. First, I would like to highlight what is the coherence. Okay, very important concept. Please understand, the coherence refers to the behavior of the memory system when a single memory location is accessed by multiple threads. Understand me? The coherence means it is a single memory location that is accessed by multiple threads. That is called coherence. Okay, so coherence ensures that right to the particular location we'll see in the order. That's a very important one. So for understanding purpose, coherence means single memory accessed by multiple threads. Okay, what is called consistency? The consistency refers, okay, it is a different memory locations. Clear? Different memory locations can be accessed by different threads. Understand? Different locations will be seen to make the sense that, okay, that different threads is executing. Understand? So I repeat, coherence means only one memory accessed by various threads, and consistency means, okay, that is different memory accessed by different threads. So what is the problem? Consistency means, for example, I write I equal to 10. Okay, one more friend is writing I equal to 11. Okay, so I write 10. Once I written 10 on this one computer or the one memory location, and all other memory locations wanted updated as a 10. So this updation will take time. Okay, before updation, other process should not, okay, update X value. That is called consistency. So consistency is the major concern over here, because consistency refers different memory locations accessed by different threads. For understanding purpose, let us consider 5 memory. All the 5 memory locations are interconnected. Okay, the thread 1, okay, writing a data on the first memory x equal to 100 on the first memory. Immediately we have a technology, consistency technology. So x100 will be updated on all other 4 memories. So this updation will happen. Imagine that 1 second. So till 1 second, another thread cannot write any value related to x I am speaking. Any value on x in any one of the memory. That is called consistency. Otherwise, for example, the first memory x equal to 100 and the third memory x equal to 200, it is a confusion happen. So the consistency is the best example for railway reservation, or that is a flight reservation. Because, for example, in Coimbatore, I am reserving a ticket, okay, between Chennai to Coimbatore. One more guy from Chennai, he can reserve the same train, same time, okay, that is Chennai to Coimbatore. So imagine that 1 nanosecond well in advance I am operating the database. My task has to be completed. During a reservation, one ticket vacancy will be reduced now. That number should be updated throughout the entire what is called railway servers memories, so that consistency will happen. Okay, so that is a coherence and the consistency, a very important one. I hope I demonstrated all the keywords, because the topic is very important. That's the reason why I took much time. And now I would like to focus what is called MCQ questions. Okay, so that is shared memory programming with OpenMP. Okay, I already explained to you what is that. The first question is, what is OpenMP? Okay, what is OpenMP? That is open multi-processing. So that is a different answers will be, OpenMP is also API, but actual abbreviation is OpenMP is open multi-processing. So this answer I would like to set. Okay. So second question, which of the following is not valid with reference to message passing? Okay, that is message passing interface, which is not valid. So message passing not valid means MPA can run any hardware through. The programming model distribution memory is true. All parallelism is implicit. So MPA not associated with this one. Okay, the common size, everything that is except the third answer, all are correct related to MPA. So that I am selecting third one. And third question, synchronization is achieved by a dash timing device which generates a period train of dash. Okay, synchronization. Synchronization means timing as well as the period wanted to synchronize. So clock generator, clock pulse, no. Third curve, synchronization, clock generator, clock pulse. So this is the correct answer. Because clock generator is a timing device and a clock is following timing device. Okay, this is not a master, not a generator, nothing. Okay. Then fourth question, /OMP underscore hello. So this is the one command used to run this OpenMP file. Where is compile, not for compilation, not for compilation of API, not for compilation, this is for running. Okay, so this is the command used to run this program. Okay, so run the OpenMP file. So this is the correct answer. Fifth question, fork join. So already I told you, that is a fork join is used for parallel design or the parallel design pattern. Okay, so this is the correct answer. Not under, other and all wrong. Okay. Sixth question, Pragma. So I told you Pragma, what is called? It is a compiler or compiler directive. So here, is a third answer, compiler directive. Okay. Next question, Pthread. Pthread is nothing but parallel thread, isn't it? So parallel thread, parallel execution model, both are the same. Parallel thread means parallel execution model. First is the correct answer. And eighth, standalone directives. So standalone directives means what? It is a executable directives. Standalone is executable directives. No parallel execution model execution. That is executable directives. So directives means executive directives. Ninth question. So parallel directives is a parallel means multi. So that is a multi-thread. Answer is multi-thread. No single thread process other and all. Parallel directives is nothing but multi-thread execution. So multi-thread. 10th question. Section constructs is Second one, non-iterative work sharing constraints, because non-iterative is a section constraint, because one section will execute only one time, so that non-iterative, then it is a work sharing constructs. Okay, it's a correct answer. 11th question, work sharing constructs are, I already told you, work sharing constructs are, third one, executable threads. No. Work sharing constructs are, first one, executable threads that can share by other threads. Correct? No. So that is a one executable threads, and that threads can share by any other threads. That's the reason why, okay, looping is possible, parallel execution is possible, section is possible. So work sharing is a common constructs. That's the reason why executable constructs are executable threads that can share by any threads. Okay. 12th question. Implicit barrier. Obviously, implicit barrier is used for scheduling. Scheduling is here. Scheduling is the correct answer. 13th question. Open get thread num. I already told you this is the method for ranking. Here is there, ranking thread, isn't it? So get the thread rank, okay, or ranking thread. So this is a command to get the rank of the thread. This is the correct answer. Then caveats, very important concept. The caveat, okay, is the mechanism to prevent race condition. Very good. Okay, that is prevent a race condition. Correct answer. 15. Runtime schedule is used to. Runtime schedule is used to schedule processes and threads during a runtime. This is the correct answer. Not idle. Not this one. Carefully understand. I hope definitely one or two questions will come related to this topic. Runtime schedule is used to schedule processes and threads during a runtime. 16th question. Dynamic scheduling. Dynamic scheduling. It refers during execution, the loop iteration is dispatched to the idle. Yeah. Dynamic scheduling means it will focus idle process and then, okay, threads will be dispatched. So the first one. Okay. Then 17th question. Loop carried dependence. Loop carried dependence. Because one loop, previous loop data is required. Which is the answer? Last one. Loop depends in the value of the previous or different iteration. Am I correct? Okay. So loop carried dependence means that, okay, it is what is called a loop dependence in this value of the previous iteration value or different iteration. So this is the correct answer. 18th. Odd even transportation. Odd even transportation is the mechanism of parallel, this one. Okay, third answer. Parallelizable, at the same time it is designed with bubble sort. So bubble sort is used for sorting a number, okay, under parallel architecture. Okay, so this one. And next question. Message queue. Message queue is nothing but asynchronous communication protocol. Asynchronous communication protocol. Why it is called this so? So message passing, one process send the data, another process receiving a data. Both the process no need to be synchronized. That means like mail. I am sending a mail to you. At the same time you need to collect. So my data will stored in your mailbox. Whenever you free, you can see your mail. Okay. So that is message queuing is asynchronous. Asynchronous communication protocol. 20th. Work sharing constructs. A very important topic. Work sharing construct means loop construct, section, all are correct only. Okay, the last question. Work construct and above mentioned three constructs. So work sharing constructs are work share constructs, single construct, section construct, loop construct, all are coming under work sharing. So that I am selecting last this choice. Okay. 21st, collapse clause. Okay. The collapse clause, it's a mechanism, okay, to understand how many loops are associated with loop constructs. The first one. Okay, it specifies how many loops are associated with the loop construct. That is called the collapse clause. Clear? Okay. Next one is coherence. Coherence, very important one. Okay, coherence means this one, single memory location accessed by multi-threads. Memory location is a single and accessed by multi-thread, multitask. That is called coherence. Sorry, this is second is answer. This is answer. Okay. And the next one is consistency. So you know very well what is a consistency. Consistency means different memory location and those data to be updated properly. For example, different memory location observable from various threads in the system. That means I already told you, okay, 10 memory locations. I stored x equal to 10 in first memory location. That data should be updated in all other 9 memory. Okay, that is called consistency. Okay, so one thread is storing in any one of the memory and all other memories wanted to update. Okay, there's a consistency is this one. Okay, 24th. What are the steps to move the value from one thread to another thread? A very, very important one. So one thread has the value that should be forwarded to another thread. What are the tasks? I think I didn't explain there. Please understand, answer is first. Okay, so first thread writes the value. After that thread, okay, flush its value. So after writing, clear its value. Clear means that the thread's value will be cleared. So written is over. Then after that, the second thread, okay, flushed its values because the thread may have some value. That value is cleared. Then after that, read the value from memory. Understand? So that first value is going to first thread value is going to second thread. So write the value, flush the value, then flush the value and read the value. Okay. So this is the answer is first one is correct. Clear? So the second is wrong. Reason because writing value and the first thread flushes. Then after that second thread read. After reading flushes means read value will go away. So that's the reason why first is the correct answer. Like this, some confused questions may be raised. And the last question, two types of locks in the Openmp is used to destroy means two locks. Obviously simple nested, okay, all the above. All the above is the correct answer because, okay, that is two locks of Openmp to destroy lock means symbol lock also we can use, nested lock also can be used. This is for linear and this is for looping. So that is all the above I am selecting. Okay, that all the 25 questions I completed. Okay, my dear students, children, I took a long time, but I hope, okay, you understand all the concept and all. My humble request, watch these videos again and again to understand the concept and give best to answer the university examination, and I assure you, you will get very good mark. Okay, and my dear children, this and all I already demonstrated, so that I didn't take much time. Okay, I hope you understood the concept. My request is, if you are willing, like our channel as well as subscribe our channel, so that frequently we would like to post new videos related to Anna University as well as related to some other placement related also later on. So it will help you. So my dear children, okay, watch this video and you will get a very good mark. All the best. Thank you.